Oh, there are lots of S on the screen. Am I audible? Great. How are you guys? All well? So today we are going to start switching. So the first question is, what is switching according to you guys? Anyone want to explain switching? If guys you can, then you should. What is switching or what is switch? Yeah, I'm good. What about you, bro? Saudi Arabia. Great. Wow. Yeah. You are 100% right. 100% right. Really appreciate. Definitely, definitely. You will be learning every day. Anyone else? He. Pavitra. What is switching? What is switch? Okay. Switch device. Switch can be software as well, by the way. Great. Very good. And it can be layer 3 as well. Yes. Why we are saying switch is a layer 2 device, by the way? What do you mean by layer 2 device? Based on physical address or work on data link layer means what? Work on data link layer means what? Means it will forward data on the basis of layer 2 information. Whenever I am saying layer 3 device, that means that device forward data on the basis of layer 3 information. Whenever I am saying layer 2 device, that means that device forward data on the basis of layer 2 information. Getting my point? Behzad, are you there? Behzad is not there. Jyoti? Jyoti somewhere. Jyoti is also not there. Oh, just a minute. Just a minute. Guys, just 1 minute. 1 minute. I am sending you the another link. There is some issue. By mistaken, I have shared the link in wrong group. So there are just wait, 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 wait. No, 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 no. Correct, correct, correct. Fine, 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 fine. No issue. thought I have shared the link in the lots of groups are there in WhatsApp. Yeah. So guys, switching. First of all, see, whenever I am saying switch, that means I am talking about layer 2 switch. By default, layer 2 switch. If I will talk about layer 3 switch, then I will mention that layer 3 switch. Done. And before starting the switching, I would like to discuss something about the switch. So let me share my screen and let me confirm if my screen is visible. Is my screen visible? Yes. So topic is switch. First thing is why we need this device, why we need switch. So guys, let's suppose I need to connect two computer together. How I can connect these two computer together? With the help of NICs, with the help of network interface card. Both PC have one LAN port. So on the LAN port I can insert RJ45 connector, and then through Ethernet cable I can connect these two PC. There is no any issue. Now these two PC can communicate with each other. PC1 can send message, file, book, video, audio, anything to PC2. But the issue is if I need to connect more than two devices, two PCs together, then can I connect PC3 now with PC1 and 2? No. No. Why I cannot connect? Because on PC1 there is no any LAN port available. In the same on PC2 there is no any LAN port available. On PC3 there is only one LAN port available. So either I can connect this PC to PC3 to PC1 or to PC2. Even on PC1 and PC2 I have to add the NICs. So guys, to connect multiple end devices together we need a centralized device, and switch is that centralized device. See, we are not going to discuss about the hub. The reason is no one is going to ask you question from the hub, and when you will learn the switch, right, after the switch, after the switching, what I will do, I will tell you something about the hub. Automatically you will get to know like how hub works, and there is nothing to learn even in the hub. Hub is just like your extension board. All ports are directly connected with each other inside the box. That's it, right? There is no any memory, there is no operating system, right? So if there is no operating system, that means we cannot configure it. Correct guys, we cannot access it. This is non-manageable device. So the centralized device which we are using to connect multiple devices together is switch. Now which type of devices we are going to connect together? So end devices, that device is called end devices in network. In network we said end devices. So end devices can be your PC, it can be your PC, it can be servers. What is server? Server is nothing but a powerful PC, you can say, right? Like on the PC, how you are using PC guys? With the help of operating system. Can I use hardware only? No. To access the hardware, to use the hardware, I have to install operating system. So on the PC I have multiple operating system, right? We have multiple option, right? We can either install Linux, we can either install Windows, correct? In the same way on the server we can install any operating system according to our requirement. So server is nothing but a powerful PC. Then third device can be printer. Fourth device can be your IP phone. Fifth device can be guys. Yeah, yeah, definitely. Camera, IP camera. Definitely we are using, bro. We are connecting multiple cameras together with the help of switch. So these are what? Centralized device. Then IoT devices. IoT devices, Internet of Things. So these are what? End devices which we need to connect together. Let's say guys, what is the requirement of company? In a in one company there can be one printer, and that printer should be accessible from everyone, right? All employees should be able to use that printer. Then server to store the data, right? I can have IP phone, some IP phone for voice over IP traffic. I can have some clients machine like PCs. Now I need to connect, these are what? Endpoints. Now I need to connect these devices together so that these devices can communicate with each other. Like these PCs, these client machines can print out from the printer or can save some data on the server. Let's say these are the employee in the company, right? Content writing, these guys are, writing content. So where these guys are going to save the content on the server, so server should be accessible from these PC, am I right? Okay, so the centralized device which we are going to use here is switch. Through one switch, what we can do, we can connect these all devices together, and after that the server, printer, right, whatever end devices are there in the LAN, that will be accessible from everyone. So on the switch you will have ports, right? Again, there are multiple switch guys in the market, so we are going to purchase switch on the basis of our requirement. Let's say I need to connect 30 PCs together, then I can purchase 48 port switch. If I need to connect 100 computer together, definitely I need what? More ports. So according to our requirement we are going to choose the switch, or even we can use multiple switch, we can connect multiple switches together. So on switches we will have lots of ports, and through these ports I can connect these and devices together like this. Now the question is how two devices are going to communicate. Is there echo guys? No, great. Now question is how these devices are going to communicate with each other. These all devices are connected, that is fine, through switch, but how they will communicate? See, for the communication, as you know, the basic requirement is source IP, destination IP, source MAC, destination MAC. First of all we need to configure IP addresses on all machines. So either I can configure IP addresses manually, or I can configure one DHCP server. I can set up a DHCP server in the network. Done. After that, should I need to configure anything on switch guys? Let's suppose I have just purchased this switch from the market. This is brand new switch, and I have connected all end devices together. I have configured the IP address on these machines. Now can these machines communicate with each other? Answer is yes or no? Yes. Answer is yes. So by default this switch has already some configuration, that is default configuration. correct, and on the basis of default configuration these devices can communicate with each other. But guys, in real time we will not use like this. According to our requirement we are going to configure this switch, right? So on the switch, first there is one operating system, right, which is going to maintain the table, which is going to maintain table to forward traffic or to forward data between source and destination. So like on the window operate on, like on your PC you can run multiple operating system. In the same way on this box, on this switch as well guys, we can run multiple operating system. According to our requirement we are going to upload operating system over here. There will be one by default operating system, right? But let's suppose I am going to add one new switch in the existing network, right, for the new employees, for the new clients. So I will purchase switch from the market and then I will update the operating system according to the existing infrastructure, according to the existing configuration. According to the existing configuration I am going to configure new switch. After that I will implement that in network, right? So definitely there is default configuration, and by default all ports of switch is up. All ports of switch are up. By default ports of router are guys down, right? So you have to run command, you have to up the port, but the by default switch port is up. So even we don't need to run no set command over here on the switch. Okay, so in the packet tracer whenever you will perform lab of switching guys, always try to choose this switch. Two nine, either you can use this one 2950 or you can use 2960. This one is also fine. Either you can use this one or this one. Done. Now see, to access the switch in packet tracer, simply I will click on the device, then I will click on CLI. But in real time how you are going to access the switch? You need one PC. You need one PC and then you need one console cable. Through console cable you can connect this switch on this cable, console cable, on console port of switch and to your PC. And after that through software, there are multiple software like Putty, Secure CRT. Through this software I can access the switch. So go to desktop and then terminal, see the terminal. Okay, now see I have access of my switch. This is how you are going to access switch in real time. Now show version. So when I am running command show version, see the output. So guys, what is this? C2960. Is it version? There is no any version of switch. Guys, we have platform of switches, not version. We have version of operating system, not switch, right? On the for the switches we have what platforms, different platforms, and this C stand for Cisco, or you can say catalyst. You can say either Cisco or it is catalyst. These are Cisco switches, you know, and Cisco have multiple platform for switches, right? And this is one of them. Fine. Then this is the version. This is the version of operating system, right? So on guys 12.1 Zero operating system, few things will be different, and this is the updated operating system, right? 15.0. 15 series is updated operating system. So Cisco IS software C2960 software, this one is the name, the version of operating system, and release software. And here you have support, technical support from the company. So for the support you can visit to this website if your switch is under warranty. Let's say if you are working in a company, right, and your switch is not working properly, so what you will do, if switch is in warranty, right, you will initiate a RMA. You are going to describe the issue to the company, to the manufacturer company, right, and then company will replace that switch. So guys, this switch is boot up with the help of operating system. Now with the help of which operating system this switch has boot up? See, like your PC, your computer has boot up with the help of Windows operating system. In the same way, this switch has boot up with the help of this operating system, and this is iOS operating system. This is iOS operating system. iOS. iOS is operating system of Cisco. And where the operating system is stored, by the way, in the flash memory. In the guys flash memory. This is a base MAC address of this switch. All the switches will have one MAC address, only one MAC address. That MAC address is called base MAC address, and this is the base MAC address of this switch. Then there is information about the motherboard number, power supply, right, part number, motherboard serial number, power supply serial number, model revision number, right, informations about the hardware. After that, switch version. So this is actually operating system version, and the image is this one, switch image, model, and configuration revision number. Configuration revision number is used to change the booting behavior of operating system, right, and we represent configuration revision number in hexadecimal, right Jyoti, Behzad, Tripti, done. So guys, this device is booted, and even you can check the flash memory of this switch. So flash, so here you can see in the flash memory we have only what, operating system, right. So if someone will ask you, or this is the exam questions, right, CCN exam question, what is the representation of operating system, right, so dot bin, we store operating system in this format, in dot bin. Right. So first of all, see, when you will purchase the switch, guys, first of all you have to set up some basic configuration, like you have to secure the switch, means you need to configure the password there, you need to configure the host name, you need to configure the description. These are what basic configuration. On all the devices you will have some basic configuration. Like, this is not like we will purchase the switch from the market and we are going to implement it in the network. No. Right. How many types of password here I can configure on this switch? No service password encryption. Okay. There are multiple types of password we can configure on this switch. See guys, where you need to configure the password, how many way you have to access this switch. On all the ports you should configure the password, right? To secure this switch you have to block all gate. So I can access this switch through console port, I can access this switch through telnet port, right, through line VTY port. So I need to configure password on both ports. We should configure the enable password, right, for the L1 engineer, let's say, so that L1 engineer should have limited access of this switch. We can configure the privilege level here. Don't worry, you will learn the privilege level later. So those are the password configuration, and by default enable password, by default password is not encrypted like Cisco 123, and so run. In the running configuration you can see the password is visible, right? So guys, if you want to encrypt all password on the switch, you can run command service password encryption, and now so run. Now you can see my password is encrypted. So these are what basic configuration of switch, that whenever we will purchase switch from the market, we are going to perform this configuration. Like we'll check the version is updated or not. We'll check the operating system by running command so version, right? Then we'll check the password. We'll configure the host name. To configure the host name, command can be host name and then switch 1. Now you can see host name is changed, right? To configure the banner, can anyone tell me how to configure banner on this switch? I want to configure one banner over here. Banner MOTD and then any special character, let's say hatch, and I am saying this switch is connected to HR department and data center, and then we'll finish with the same special character. Now whenever you will access this switch, you will get this banner, see here, right? Whenever anyone will access this switch, close it and let me access the switch again. Terminal, say OK. This was the older output. Now see, once I will hit enter, it will give me the banner, right? So these are the basic configuration guys, and we are going to perform it. Now how to check the base MAC address of switch? See, when I'm running enable command to enter in enable mode, it's asking for password, right? And password was Cisco 123. Now how to check the base MAC address? So version, right? This command will show me the base MAC address of switch. MAC address is, what is the length of MAC address? 848 bits, very good, right? So see the MAC address from the range. Now on the switch guys, see in the real time what will happen? In the real time what will happen, you have connected these client machines, right, to this switch. Now what you need to do on this switch, you have to find, let's say, where Anil is connected, where Behzad is connected, right? Which ports are connected port, which ports are not connected ports, where I need to configure the password. Let's say I want to allow only Rajnish on this port. Rajnish is the employee of my company, right? And I want to allow only Rajnish on this port. So I can configure the switch in such a way so that it will allow only one MAC address, the MAC address of Rajni's PC on this port only. Getting my point? So what we need to do, we need to find the ports here, right? So guys, see, all end machines have what? MAC address. So on the basis of MAC address of my client machine, I can find the port on switch. Or even I can check the connected port, non-connected port, disabled port, right? So the status of, if I will talk about the status of ports, so you will have three status. Port status can be status, port status. It can be, guys, connected, it can be non-connected, and it can be disabled. Connected means the port is connected with other device. Not non-connected means port is not connected with any other device. And disable means port is down. Disable means, guys, port is down. So the command to check let's say status of the switch port is show interface status. So this command is going to give me the status of all ports on the switch, right? And let's suppose on this switch we have 100 ports, guys. 100 ports are there, or 1000 number of ports are there on this switch. So it will be complicated, right, to find a particular port here, right, to find a status of a particular port. So what I can do here, I can define the interface type, and then interface ID. Show me the status of fast Ethernet 0/0, right, like that. Now guys, on this switch, let's say this is 0/1 port of the switch. 0/1 port means this 0 is slot number, this 1 is the port number, means in slot number 0, port number 1, right? The device who is connected over here is PC1, whose MAC address is 0A, and this is PC of Vikas, let's say PC of Vikas. So on this switch, what I can do, I can write one description on 0/1 port, right? Simply interface fast Ethernet 0/1, or I can say description, and then connected to, I can say connected to Vikas. If we are sure that every day Vikas is going to connect their PC on this port only, right? By the way, description is required, guys, on the static device, like for the fixed devices, for the servers, right? We are not going to unplug and plug the server every day here, am I right? So for the server, we can configure the description. These are the basic about switch. Now even I can run command like this. So interface status, and then I can say include connected. Only show me the connected port. This command will show you the connected port. Then the another requirement in real time can be, what can be the another requirement in real time, guys, on the switch? Maybe you need to check. Yeah, tell me. So IP interface brief, okay, that is fine. To check the IP address, we can run command so IP interface brief to check the IP address on switch. But for now, just suppose we don't have any IP address over here on this switch. Okay, just assume you are using this switch to connect multiple devices together, right? This is a centralized device here. Now guys, my next requirement can be, let's say I am troubleshooting this switch, right? or I am monitoring this server, or I am monitoring the beacons, right? So how many traffic beacons is forwarding to the switch. So I can check how many packets have entered over here, how many packet has hit on this interface, and how many packet has out from this interface. Means total number of packets, total number of packets on one port of switch. That can be my requirement. My requirement can be binding MAC address of because PC on a particular port, or binding MAC address of server on a particular port. This can be my requirement. So here guys, is topology visible to all? Yes. So see, I have two switches here, switch 1, switch 2. Switch 1 is connected with 2 PC, PC1, PC3, and switch 2 is connected with 2 PC, PC2, PC4. Now can anyone tell me why we have two link here between switch 1 and switch 2? For the, yes, for the backup. Because guys, the link between switches are shared, right? Link between switches are shared. Like both PC on switch number 1 is going to use link between switch. So let's suppose we have 100 PCs on switch number 1 and 100 PC on switch number 2. So all 200 users are going to share this link. What I'm saying, let's assume that we have only one link, right? We have only one link between switch 1 and switch 2, and the bandwidth of this link is, let's suppose, 100 Mbps. Fine guys, and we have 100 user here, 100 user here. So all these users are going to share, right, this link. So one user will get how many bandwidth between switch 1 and switch 2? 0.5 Mbps, am I right? One user will get 0.5 Mbps bandwidth. If all are communicating at the same time, right, then each user will get 0.5 Mbps bandwidth, right? So that's why between switches we have multiple link, and I will tell you the solution of this also later. This is also the note the correct real-time scenario, right? Like we are not using we are not connecting switches like this. Done guys. Now let me access this switch here in the EVNG, and so version. Here also you can see the output. You have same output, right? But guys, you are not able to see the base MAC address here. Is base MAC address visible? No. Right? So this is the issue of simulation software. Right? But if I want to check the MAC address, base MAC address, I can check. I have multiple options. Now you can see the base MAC address of this switch. This one is the base MAC address of this switch. Now how switch is going to forward traffic between two PC? For that, my first topic is what is switching. For that, my first topic is what is switching. And guys, hope now this is clear. Like switch, what is switch? Switch is a networking device, layer 2 device you can say, which is used to connect multiple end devices together, right? And we have two types of switch: layer 2 switch and layer 3 switch. Layer 3 switch, the switch which will forward traffic on the basis of layer 2 information based on the on the basis of MAC address is known as layer 2 switch, and the switch which will forward traffic on the basis of layer 3 information will be which is IP address is called layer 3 switch. If I will give you some switches, some example of layer 2 switch, so you can say Cisco 2960, the most popular switch. This is not one switch, this is series of switches, right? This is series. We have multiple switches. These are what? Access layer switches, which is used to connect and devices together. Then the another series is a Cisco 2950 series switches. In the same way, if I will talk about the layer 3 switch, layer 3 switch, and this is layer 2 switch. So example can be your Cisco 3550 series switches, then your Cisco say 3760 series switches. These are the popular layer 3 switches. So now why we have layer 2 and layer 3, two types of switches, guys? And where we are using layer 2 switch, where we are using layer 3 switch? Layer 2 switch is used to connect end devices, and layer 3 switch is used to perform internal routing. But I cannot use layer 3 switch instead of router, right? Let me tell you something about the Cisco network architecture. In the Cisco network architecture, there are three layers. By the way, there are two types of architecture, right? Cisco network design, we can say design. We have two tier design and we have three tier design. Three tier design. Two tier design means we have only two layers, right? First layer is the access layer where I am going to connect end devices, and the devices, centralized devices which I am using to connect multiple end devices together is access switches. These are access switches. Like this, I can connect all PCs, server, printer, IoT devices, cameras, IP phone, these devices together. I can have lots of end devices here on switch 1. I can have lots of devices on switch 2, and I can have lots of devices on switch 3. Later we will see how to combine these three switches in a single switch. Because guys, if I have three switches, that means there are three control plane. That means there are three operating system, right? But in real time, if we need more ports to connect more end devices, we can combine these switches together, right? So these are what access layer switches. We can say this is access layer switch 1, this is access layer switch 2, access layer switch 2, this is access layer switch 3. So why I am using access layer switch here? To connect end devices together. Now I need to connect these all access layer switches together. So to connect these all access layer switches together, I can use distribution layer switch. Means your layer 3 switches. And why I am using two layer 3 switch? For the again redundancy, for the backup, for the load balancing, for the traffic distribution. So this is my D switch 1 and D switch 2, right? And then I can connect access layer switches to distribution layer switches like this. You need to understand how to configure this type of scenario from the scratch. Now can all N devices communicate with each other? Answer is yes. Is this network reliable? Yes. Can I perform load balancing? Yes. So guys, suppose this is a network in a building, and if directly I am going to connect this network to internet, then this is a two-tier network because there are two layer only, right? This is access layer, this is access layer. I will discuss more about this architecture later, and this is distribution layer. Distribution layer. So if there are two layer only, that means that design is two-tier design, right? And now guys, here I can use one router. See the difference between layer 3 switch and router. First of all, the layer 3 switch is the switch which forward data on the basis of IP address, right? That means layer 3 switch can perform routing, can connect multiple networks together. But layer 3 switch cannot run edge technology, guys. Edge technology means like translation NAT. It cannot make communication between private and public network, right? Between internet and your LAN. So here I can use what? Router for the edge technology, so that I can configure the edge technologies over here so that my end devices can access internet. Is this network reliable? Full reliable? Full reliable? No, right? Because we don't have any redundancy for core layer. At core layer I have only one device. So if core layer will goes down, then my entire network will goes down, right? Not the internal connectivity will goes down, but external connectivity will goes down. Like this. Now suppose this is a branch office, right? And like this guys, I have 1,000 branch offices on the globe, and all are connected through internet. So if router one means core layer will goes down, then connectivity from other branch offices will goes down here. Core layer. So actually these devices are access layer switches, right? Access layer switches means 2960 switch, right? Or 29506, and these are L3 switch, layer 3 switch, 35503 switch or 37603 switch. The benefit of using layer 3 switch over here is we can configure routing between layer 2 and layer 3, between distribution layer and core layer. We can configure routing. Yeah. Yeah, definitely. See, distribution layer is connected with two layer, core layer as well as access layer. So between access layer and distribution layer, here STP will run, and here routing means your routing protocol can be OSPF is running. So this is my core switching network, and this is my routing network. Here we are doing what? Routing. Here we are doing what? Switching. But guys, this is a very small topology, right? In real time you will have 100 number of distribution layer switches and 1000 number of access layer switches in data center. just assume the design, right? I cannot design that topology on my computer screen, right? So I will teach you everything in simple topology, but you will implement that in large topology. The concept, the configuration, the protocol is going to be same. There is multiple configuration, like these ports will be trunk port, there will be many VLANs, right? So SVI interfaces will be there. One device will be acting as DHCP, or I can have a separate DHCP server here, or I can enable DHCP service on layer 3 switch. And now guys, let's suppose this user is complaining that I am not able to communicate with any device. I am not connected with internet. Even I have connected my port to the switch. How you are going to troubleshoot? First of all, you are going to troubleshoot what? Physical cable. First you are going to check physical cable. In, in the physical, also first you are going to check what? The ports. You have inserted the cable properly or not, right? RJ40 for connector is inserted over here properly or not. If it is properly, when you will put the RJ45 connector, on the switch, if it is inserted properly, you will get like good sound. So this cable can be faulty, the port can be faulty, right? Maybe the cable is not inserted properly. Those are what? The physical issue. And after that, the second issue is going to be, guys, configuration issue, right? In the configuration, you are going to start troubleshooting from layer 2. First of all, you will troubleshoot layer 2 issue. At layer 2, actually on the switches, by default one protocol is running, that is CDP protocol, Cisco Discovery Protocol, right? So CDP is nothing but a protocol, layer 2 protocol, which is used to check connected device. Like I want to check how many devices are connected on this switch. I can check the CDP neighbor. It will show me all connected devices. There are two protocols. CDP is Cisco proprietary protocol, and for other vendors we have LLDP protocol. Got it? Yeah, both are same, but you can only enable CDP on Cisco devices, right? And LLDP is open standard protocol. Yes, for other devices. If let's say I am connecting two switch, one is Cisco and one is Juniper. So in this scenario, I cannot enable CDP on Cisco switch, right? I have to enable LLDP even on Cisco switch as well. By default, CDP is enabled, so we have to change the protocol. Like in this scenario, see, I have access of my switch. Here I can check the connected port, like connected device. I can say show CDP neighbor. It will show me all connected device. You can see on 0/3 port, which device is connected, guys? Name of device PC3. On 0/2 port, which device is connected? PC1. On 0/0, which device is connected? Switch 2. On 0/1, which device is connected? Switch 2. And the hold on time. We will learn the CDP protocol, but by default hold on time is 180 seconds. And these devices are actually exchanging the CDP message. Are exchanging CDP message. Clear, guys? Any question till here? Hello time of CDP is 60 seconds. So CDP and I can say what, so CDP entry detail. So what it's saying, sending CDP packet every 60 second, sending a hold on time value of 180 second, right? So hold on time is 180 second and hello time is 60 second. Now the question is how switch is going to make communication between two device. Guys, to understand communication between two device, let me revise the layer 2 header, because switch is going to forward traffic on the basis of layer 2 information, that means the MAC address, and MAC address is encapsulated at which layer, layer 2. So for next few classes we are going to discuss about layer 2 forwarding only, layer 2 forwarding only, layer 2 forwarding. And layer 2 forwarding is done, it is done on the basis of Ethernet header, on the basis of Ethernet header. So you all know the Ethernet header. Like guys, I have two PC1, PC1 or PCA and PCB. If these two PC want to communicate with each other, both PC need source MAC, destination MAC, source IP, destination IP. Let's say PC1 MAC address is A and PC2 MAC address is B. You can take example of any message. Let's say PC1 have one packet, this is, let's say, one book, CCNA book, and PC1 want to send this book to PC2. So PC1 cannot send this CCNA book directly to PC2. PC1 have to encapsulate this packet first, right? Like they have to add the address. Can you send later directly to your friend? No, you have to add the address, right? So you will put your letter in the envelope, and on the envelope you are going to add source address, destination address, right? So putting letter in the envelope and adding address on the envelope is what encapsulation. Encapsulation means adding extra information with actual data to forward the message to the correct destination, right? So PCA is going to add some extra information, right? Like source IP, destination IP, source port, destination port. But we are going to discuss the layer 2 extra information, that will be source MAC, destination MAC. So guys, this PC is going to add source MAC and destination MAC with the help of a header, right? That header is known as Ethernet header. Ethernet header. Right? And if you will Google it, like Ethernet header, see multiple informations are there. Ethernet, and we have multiple types of Ethernet header. I will discuss the latest one, Ethernet header. See, multiple types of headers are there, and in each Ethernet header you will see source MAC and destination MAC. In the each header there will be source MAC and destination MAC. Are you able to see source MAC, destination MAC here? Yes. So actually layer 2, at layer 2 your ARPA protocol is working. Which protocol is working? ARPA. To verify it, so interface, and the interface type and ID E0/0, let's say E0/0. Somewhere you will find the protocol, layer 2 encapsulation protocol. Mm -mm -mm -mm. Yes, see, encapsulation protocol is ARPA. So ARPA is going to add what? Ethernet header with the actual message. Actual message is my CCNA book, right? So ARPA protocol needs some information like source MAC, destination MAC. Where it will find the destination MAC? It will look up their ARP table. It will look up their ARP table. These are the detailed information about this port, guys, on switch. What it's saying, Ethernet 0/0 is up, means their status is up, and their line protocol is also up. That means the port which is connected with device, so the newer device is also up, and this port is connected. This is what status can be connected, non-connected, and disable. After that, hardware address, MTU bandwidth, delay of this interface, reliability, TX and RX load, encapsulation protocol, loopback node set, keep alive. So by default, switch is sending one keep alive message after every 10 seconds. After every 10 seconds, it is sending one keep alive message. The duplex is full. Speed is auto. That means it will negotiate the speed from newer device. Media type is RJ45. Input flow control is off. Output flow control is unsupported. ARP type is ARPA, and ARP timeout is 4 hour. So the switch is going to reset the ARP table hour for hour. Last input and output. The last time when this switch has received the message over here. After that, these are the queue for the input and output queuing. We will see these all later. Then guys, how many packet has entered on this port? 132. 132 packets has entered. And the length, total length of messages on this port is, total length of messages which this switch have received on this port is this one, 21873 bytes. And how many message, broadcast message have received over here? 83. And how many packet it have sent from this port? And this value is keep changing. See, so IP interface, not so IP, so interface is 0/0 and include, I want to see, let's say what, packet input, packet input, packets input, packets input. So see, 50, 150. After some time you will see this value is increasing. Now you can see the 52. That means what? That means by default some protocols are running over here. Even on the LAN port which is connected with PC, like 0/2. So interface is 0/2 include packets input and packet output. See, both value is increasing. That means it is receiving, earlier it was 202, now it is 203. And the odd packet is also, you can see, increasing. Earlier it was 1084 and now it is 1088. That means switch is sending some kind of message from their port, right? And it is receiving as well. It means, guys, whenever a device is generating a message, that means protocol is running there. Device cannot generate any message, right? The protocol is generating the message. So as I have shown you the keep alive, switch is sending one keep alive message after every 10 seconds. That is one message. The another protocol is, you have already seen, CDP. So if I will disable these two protocol, do you think switch will not send any message? interface is 0/2, no keep alive. Now it will not send any keep alive on this port, and no CDP enable. By default CDP enable command is running, right? So to disable the CDP I can say no CDP enable. Now guys, do so interface is 0/2, and the packets output include 1145 1146. Still switch is sending some packet. Getting my point? I have disabled the CDP, I have disabled the keep alive, still it is sending. Do so interface is 0/2. If you are thinking that is keep alive is still enabled, so now you can see, bro, no keep alive, but still the packet count is increasing, right? Guys, the another protocol which is running is a spanning tree. So say no spanning tree for VLAN 1. I've disabled the spanning tree as well. Now do so interface is 0/2 include packets output. 83, right? So whatever protocol is running, like now VTP is running and many more protocols are there, right, which is running on switches. We are going to learn these all. Leave it for now. Try to focus on the Ethernet header. So guys, if PC1 and PC2 want to communicate with each other in this scenario, what will happen? PC1 is going to add what? Source MAC and destination MAC. How it will add source MAC and destination MAC? With the help of Ethernet header. And in the Ethernet header there will be some informations, right? Like these informations. Can anyone explain Ethernet header here, guys? About these informations? Like what is the use of preamble field here? What is the use of preamble field? Guys, doesn't matter you are right or wrong, please participate even. Very good. Very good. Very good. See, interviewer can ask you this question. Anyone can ask you this question. Your team member can ask this question. So whenever I am asking question, at least try to participate. And the length of preamble field is 7 bytes. So the preamble field is going to tell from where the actual frame message is starting, because at layer 2 this PC is going to add what, guys? Ethernet header. That means at layer 2 there are two information, extra information header, right, and the actual message. So from where this frame is starting, how machine will get to know? With the help of this field, preamble field. Value in the preamble field will be always like this: 1 0 1 0 1 0 1 0, so on, like this, right? So this is a series of ones and zeros, and even this field is used to synchronize the clock, used to synchronize the clock, or you can say it is a signal, it is a small signal that tells the receiver machine get ready to receive the data. be ready to receive the data, right? So this is just a signal who is indicating that from here your frame is starting. Then what is this one? See, this one is very clear with the name start frame delimiter, and here value will be 10 10 10 11 always, and the length is 1 byte. This field indicates the start of actual frame. It will tells to receiver machine about the Ethernet frame. Guys, maybe see a PC need to have one at least, there should be a limit that minimum size of frame should be this one. Minimum size of frame should be this one, then only PC can transmit it. But if the length is less than that, then PC need to add some extra information as well, right? That's why we have these fields. But don't worry about these fields much. The important field is this one, destination MAC address. What will be destination MAC address? B, right? So destination MAC address B. And where PC A will find destination MAC address? In which table? In the ARP table, right? After that, source MAC will be A. After that, length, total length or header length. This is header length. After that, your actual data, and then we have what? CRC for the error detection. So before sending the data, what PC1 will do? This PC1 is going to put all data in one algorithm. And it will find one hash value. That hash value is, let's say, at the rate 123, and it will put that hash value in the CRC field at the rate 123. And guys, there is one more important field, that is type field, which will specify the protocol, upper protocol. Like at layer 3, protocol can be what? IPv4, IPv6. At layer 2, protocol can be ARP. So in the type field, there will be value of the protocol, right? And then sender machine is going to send it to receiver machine PC2. When PC2 will receive, first of all, PC2, without checking anything, PC2 is going to also put the data in the algorithm, and it will find the hash value. If hash value will match, then it will get to know that this data is not modified, there is no any error. If PCB will get any different value, then PCB will get to know, no, this data is not correct, there is some error. It will simply discard it. If it will accept, then it is going to check what? Destination MAC. And now guys, tell me, after checking destination MAC, will PC2 accept it or it will drop it? In two scenario, PC is going to accept it. Number one, if destination MAC address is the MAC address of PCB, and if destination MAC address is broadcast. Because if it is broadcast, then it can be for me as well, right? So this machine have to check the more information. Apart from these two address, if there will be any other address, simply PC is going to discard it, drop it. Clear? Clear, guys? Now try to focus. Yeah, CRC. Bro, actually, CRC is used to check the frame is correct or not, like frame is error free or not. For that, the juicer, like juicer, we have multiple algorithm in networking. Through algorithm, we are calculating the hash value. Like the one algorithm is MD5 algorithm. See here in the Google, if I am saying MD5 calculator, this is one algorithm, right? So what will happen? Whatever data I will put over here in this algorithm. Let's say my data is hello, how are you, how are you. So this algorithm is going to generate one hash value for me, right? And that hash value is this one, right? Now I am going to copy this hash value and I will add this hash value with data, and after that I will send to you. Now let's suppose between me and you someone have modified the data, they have changed the data. You two, let's say they have add one dot here, single dot. So now if you will generate the hash value, see you will get the different value. Getting my point? See the different value. So if you will modify the data, right, then it will generate the different value. If value is different, that means data is modified, right? So whenever a machine is receiving data, right, any message is always check the error, like this data is error free or not. We have two more important and most commonly used protocol. One is MD5 has, and other one is SA. SA1 has algorithm. On your switch as well, here you can check is there any CRC error on port. In the real time, guys, for troubleshooting, this command is very important. Interface is 0 by 2. Sorry, so interface is 0 by 2. To find the errors, like you can see CRC error 0. These all are error, over and ignore, input error, CRC error, gains, runs. These are errors. In real time, you will be troubleshooting these things. Like this is your router R1, and here is your LAN network, right? Building, in the building, and this router is connected with two ISP, ISP1 and ISP2 internet 1 and internet 2. Why you have two ISP connectivity? For the backup, right? So you will see in real time, you will be troubleshooting CRC error over here on this link, because you will configure the router in such a way so that whenever ISP1 bill goes down, it will start forwarding all traffic towards ISP2 automatically. You will learn the configuration of that failover. That is fine. But the issue is, if ISP is not down but there is slowness on the link, if there is some other error, link is up but there is a reliability issue, this link is not reliable, in that scenario your router is not going to fill over the traffic, your router is not going to shift traffic from ISP1 to ISP2. So you have to identify why I'm getting CRC error here, why I'm getting rents here, gains here, over and here, ignored here, input packet error here. If there is slowness or packet loss when you are sending 10 packet, right, to the internet, and you are getting 5 packet loss, right, you are getting reply for 5 packets only, and now you have realized that 5 packets is dropping on this link, how you are going to troubleshoot it? So in real time you will have these types of scenarios. See, both machine have already information about that algorithm, na? Bro, both machines are designed according to OSI model. Whatever protocol, see, this is a rule for networking. Yesterday I have told you that there is one component, that is protocol. Protocol is what? Rule. Like, why I'm speaking in English, this is a rule for me. If I want to teach everyone, I have to speak in English only, because there is someone who don't know the Hindi, don't know the English, sorry, other language, Hindi, right? So I have to speak English only. So if these two machines want to communicate with each other, both machines have to use same algorithms. Encryption algorithm, right? Compression algorithm. Like, let's say on the PC number one, you are compressing a file in the zip file. So can PC2 decompress it by any other algorithm? No. They have to unzip it by using the same algorithm, right? In the same way, both machines have already the algorithm. Now guys, in the Ethernet header, you will have source MAC address A and destination MAC address B. Source MAC A, destination MAC B. And your switch is going to forward traffic on the basis of this address only. Switch is going to forward traffic on the basis of this address only. Apart from source MAC and destination MAC, the important fields are type field, and guys, later on you will understand the VLAN. So on the trunk link there will be VLAN ID as well, right? VLAN tag, you can say VLAN tag information. So these are the important information inside layer 2 header to understand the switching, like how switch forward traffic. Done. Now clear? Any question? Anyone? No question? Yes. So now switching. What is switching? So guys, you can say switching is a process. It is a process of transmitting data from one port to another port. Question is types of switching. Types of switching. Yes. Anyone? Layer 2 switching, layer 3 switching, layer 4 switching. Now what is layer 2 switching? So switching means transmitting data from one port to another port, and layer 2 switching means transmitting data from one port to another port on the basis of layer 2 information, on the basis of layer 2 address, and transmitting data from one port to another port on the basis of layer 3 information is known as layer 3 switching, and forwarding traffic data on the basis of layer 4 information between two ports is known as layer 4 switching. So guys, your layer 2 address is MAC address. MAC address. Your layer 3 address is IP address, and your layer 4 address is port number, right? So now we are going to understand layer 2 switching. Don't worry about the layer 3 switching and layer 4 switching. We'll see later. So the types of layer 2 switching. And nowadays we are talking about the Ethernet switch, right? Everywhere nowadays we are using only Ethernet switch, guys. Earlier we had different switches as well, right? But nowadays we are not using those switches. If someone will ask you like types of switches, types of layer 2 switch, types of layer 2 switches. So first one is Ethernet, the most commonly used switch, Ethernet. And the second one is frame relay. Earlier we had one frame relay switch. Nowadays it is not in use, no one is using. And the third one was ATM switch, right? So you don't need to learn these two switch, you only need to learn the Ethernet switch, right? So Ethernet switch forward traffic on the basis of Ethernet address, which is the MAC address, right? So let's say I have one Ethernet switch here, Ethernet switch, and this switch has two PC, one over here and one over here. Today is the first day of switching, that's why I'm going guys slowly, very slowly, but definitely will increase some speed. This is switch, and I will denote switch with SW, right? PC1, or you can say A, PC B. PC1 MAC address is A, PC2 MAC address is B. This is Ethernet switch. Ethernet switch. Now, function of Ethernet switch. Most important for the switching. Functions of Ethernet switch. First function is guys address learning. Address learning. The second function is forwarding. Forwarding. The third function is filtering. And the fourth function is loop avoidance. Loop avoidance. These are the function of switches, right? So what we need to learn, how switch is going to learn MAC address, how switch is going to forward data, how switch is going to filter the data, and how switch is going to avoid loop. Clear? Now address learning. First of all, address learning. So guys, always keep in mind, whenever, let's say this is 0/1 port and this is 0/2 port. Whenever switch will receive any frame on any interface, it will learn the source MAC address. It will learn the source MAC address. So when I will configure IP address on PC number 1, 10.1.1.1, what will happen? Will switch learn MAC address of PC1? When I will configure IP on PC1, will switch learn MAC address of PC1, guys? Tell me yes or no. What about that? Answer is Yes. Answer is yes. Sorry? No, no, I'm saying when I will configure the IP address on PC, at that time switch will run MAC address of PC1. Answer is yes. No, no, no. That is also fine. But see, when I will guys configure IP on PC1, will PC1 check duplicacy? That is this IP address duplicate or not? Yes. Whenever we are configuring IP address to the machine, first of all, machine checks duplicacy, that this IP address is duplicate or not. And to check duplicacy, machine is going to generate what? Gracious ARP, that is GARP. Machine is going to generate GARP, Gracious ARP. In the Gracious ARP, source IP will be 10.1.1.1. Destination IP will be broadcast. No, not broadcast. Destination IP will be also 10.1.1.1. Same. That means which machine will generate reply? 10.1.1.1. Right? Source MAC will be A and destination MAC will be broadcast. All F. Now this PC is going to forward this message to switch, and on switch will receive this message on 0/1 interface. It will learn the source MAC address, which is what? A. And on the basis of destination MAC address, which will takes forwarding decision. On the basis of destination MAC address, which takes forwarding decision. So it will first it will learn the MAC address, source MAC A, then it will check destination. Oh, destination is broadcast. Let me forward it to all the ports except the receiving port. Right? And is there any machine who is using this IP address? No. So if PC1 will not receive any reply message within a limited time, it will get to know that there is no one who is using this IP address. That means this IP address is unique. Then PC will assign that address on their interface. But let's suppose I have configured already same IP address. Now I have configured this IP on PC1. Switch have learned the MAC address, which have one entry in their MAC address table that on me 0/1 port a device is connected whose MAC address is A. Now I am going to configure same IP address on PC2 10.1.1.1. PC2 is also going to generate what? ARP, Gracious ARP, GARP. In the GARP, source IP will be 10.1.1.1, destination IP 10.1.1.1, source MAC B, destination MAC all F. It will forward to switch. On switch will receive it. Switch will learn the MAC address of PC2. On 0/2 interface, a device is connected whose MAC address is nothing but B. After that, switch will check destination MAC. Destination MAC is all app broadcast. It will forward to switch 1, sorry, PC1. And PC1 will check destination MAC broadcast. Okay, let me check the rest information, because if it is broadcast, then it can be for me also. It will check layer 3 information. It will see destination IP is 10.1.1.1. Oh, this is my IP address. Someone have sent message for me. Let me generate the reply, right? PC A will generate the reply. And on PC2 will get the reply message. It will get to know that no, this IP address is definitely duplicate. It will give you the error that duplicacy, that this IP address is duplicate, not unique. Guys, even in the packet tracer you can verify it. What I am going to do, see MAC address table of this switch. So MAC, sorry, password was Cisco 123. Yeah, so MAC address table. Switch maintain MAC address table to forward data, forward traffic. And by default, see, there is no any entry available in the MAC address table of switch. Table is empty. There is nothing. Now guys, I am going to connect some PC over here with this switch. The MAC address is empty. Now let me connect some PCs here. PC1, PC2. Done. Now you can see the line protocol of these ports are up, right? And these ports are still not up. It's taking time. It will take 30 seconds. We will learn why it's taking 30 seconds, because by default spanning tree protocol is running for loop avoiding. Now you can see these ports are up, and again you can check the MAC address table. Still MAC address table is empty. There is no any entry. Now I am going to configure IP on PC number 1, and before that let me open the simulation mode so that it will generate the message. See, once I will configure IP 10.1.1.1, it have generated one message, right? Which type of message it is? It is ARP message, right? If you will open this, see the source IP 10.1.1.1, destination IP 10.1.1.1. Source MAC is the MAC address of PC, destination MAC is broadcast, right? Now this PC is going to forward it to switch, and switch will forward it to PC number 2. PC2 will simply discard it, correct? But now you can see the MAC address table. It have learned the MAC address of PC1. Guys, please keep yourself on mute if you are not speaking. There are lots of people. Please don't disturb. Yeah. So what happened here? On switch have received one message on 0/1 interface. It have learned MAC address. This is the MAC address of PC1. This was the source MAC address in the Gracious ARP, right? So what switch is saying? I have learned this MAC address on which port? On 0/1 port. And how I have learned it? Dynamically. Guys, we can also make entry in the MAC address table of switch, correct? And VLAN ID is 1 by default. Don't worry about the VLAN. Leave this information for today. Tomorrow we will discuss the VLAN. In the same way, when I will configure IP on PC2, it will also generate Gracious ARP 10.1.1.2 and subnet mask. It will also generate the Gracious ARP, and let me take you the switch and so MAC address table. Now you can see switch have how many MAC addresses? Switch has how many MAC addresses, guys? 2. Got it? You will get the error message, bro. Duplicate. What is the error? This address is already in the network. Are you able to see the error? It's again depends on operating system, right? Like how operating system is going to give you the error, right? In the Windows operating system, guys, it will give you duplicacy error. Like this IP address is duplicate, right? Windows operating system is giving error like this. That's not matter. Now on PC number 1 here I am going to configure the IP. Enable and so IP interface brief. IP is already there. On PC3, so IP interface brief. IP is already there, right? Now let me show you the MAC address table of switch. Enable and show MAC address table. See the MAC addresses, right? Now clear MAC address table. So MAC address. Again you can see there is one MAC address on 0/2 port. Let me do one thing. Actually by default protocol is, some protocol is running on switches, so these switches are exchanging messages. That's why it is learning again MAC address, right? Interface range E 0/0 and E 0/1. I'm saying shut down. I've done these 2 ports. So MAC address table. Now you can see we have MAC address on LAN ports. right, where PC is connected. By default, PC is also sending what? Keep alive messages. Now guys, till how long switch is going to store this MAC address in their MAC address table? That is MAC aging time. That is MAC aging time. So MAC address table and aging time. Global aging time is 300 second. So whenever switch will learn a MAC address dynamically, it will store that MAC address in their table for 300 seconds. After 300 seconds, it will automatically remove that information. And between 300 seconds, if it will receive again any message right on that port, then definitely it will update the entry. Definitely it will update the entry. Done. Now I want to configure a permanent MAC address. I don't want to set the MAC aging time. So what you can do, you can change the type here. You can configure the static entry. Like let's say PC1 is the server, right? Who will be always connected on this port. In that scenario, what we need to do, we need to combine the MAC address of server on the port. Like I can check the MAC address of PC1. PC1 is going to 0/2 port. So this is the MAC address of PC1, right? And guys, I have told you some more command here. So interface status. So you can use this command. So interface status. You can see 0/2 is disabled, right? I have run shutdown command. 0/2 and 0/3 are connected. If I want to see only connected port, I can say show interface status and include connected. Show me the connected only, right? If I want to see the disable port in the troubleshooting, so I can say disable. It will show me the disable ports only, right? Even I can say show interface see this is MAC address of PC1. I want to know, I have MAC address of server and I want to know server is connected on which port on this switch. So I can say show MAC address table for this address. Not like this. MAC address, sorry, address, and now I can put the address. It will show me the interface. I can find the MAC address from the interface. I can find the interface from the MAC address. I can check the input packet. I can check the output packet. I can check the status. These all are troubleshooting command. Now guys, to understand why we need to configure a static MAC address, try to understand the flooding, switch flooding. Switch flooding means you can say types of forwarding on switch. So topic, types of flooding on Ethernet switch. So the number one is broadcast flooding. Broadcast flooding means if the message is broadcast, like your gracious RP is broadcast, so in that scenario definitely switch will forward one copy of that message from their all interfaces. The second type of flooding on switch is unicast flooding. Unicast flooding. So see, whenever switch will receive a data, it will learn the source MAC. On the basis of destination, it will take forwarding decision, right? So where it will find the destination MAC address? In the MAC address table. So it will look up their MAC address table. If entry is there in the MAC address table, then only switch can perform unicast. Otherwise, switch don't know what is the exit interface for this destination MAC. Let's say this switch is receiving a frame, a data where destination MAC is C, source MAC is anything. let's say D, and destination MAC is C. So switch is going to check their MAC address table. Is there any entry available in MAC address table? No. Now what switch will do? Switch have to forward one copy from their all interface, correct? So this type of flooding is a non-unicast flooding. A non-unicast flooding. And guys, if the destination MAC is B, source MAC is anything C, destination MAC is B, it is receiving on 0/3 interface. First it will learn C MAC address on 0/3 interface. A device is connected with MAC address C. Now what is the destination MAC? B. Let me check the MAC address table. Okay, for B MAC address my exit interface is 0/2. It will forward it from here. This is what? Unicast flooding. Unicast. This is how switch perform unicast flooding. And the third type of flooding is a non-unicast flooding, right? A non-unicast flooding. This is an interview question. When switch will perform a non-unicast flooding? So guys, if switch don't have entry for the destination MAC address in their MAC address table, then switch have to forward one copy from their all interface except receiving interface, and that is known as a non-unicast flooding. And the fourth type of flooding can be multicast flooding. If the destination is multicast flooding. Now you will not understand the multicast flooding, but when you will understand the VLAN, that time I can easily make you understand the multicast flooding. Multicast flooding means forwarding packet from multiple ports, not from the all ports. Yeah. The name is unicast means message is unicast, right? But the destination is unknown. Message is unicast but destination is unknown. That's why switch is doing what? A non-unicast flooding, right? Now let's come to this scenario again. In this scenario, this is my server, and let's suppose outside users or many users are accessing this server multiple time in a day, right? In an hour. So in this scenario, switch is going to learn MAC address of server in their MAC address table, and it will flush that information after 300 seconds. Means after 300 seconds, if anyone will try to access the server, switch have to perform what? A non-unicast flooding, right? Switch have to perform a non-unicast flooding. And guys, if switch is performing a non-unicast flooding, that means it is using their more CPU utilization, because forwarding packet from one interface and forwarding packet from their all interfaces, like 100 interfaces, there is huge difference. There is huge difference. Switch have to make a multiple copy of that message. So in real time, you have to reduce the non-unicast flooding, right? And this is again an interview question, how to reduce a non-unicast flooding. So the first option is increase the MAC aging time. But if you will increase the MAC aging time, then make sure you are increasing MAC aging time for a specific PC. Otherwise, what will happen? Let's say if you have increased MAC aging time to 10,000. So guys, there is chance that MAC address table of switch can get full, right? If the switch is have capability to store only 10,000 MAC address in their MAC address table, and it have received 10,000 messages from different users. So in this scenario, what will happen? Now switch don't have any space available to store new MAC address. So if any other user will try to communicate, switch is going to drop the message, discard the packet. So that's why we have MAC aging time. That whatever users are communicating right now, just store information about that information, that users only. If they are not communicating, then flush it, clear your MAC address table, right? But guys, in real time, for some specific users, you have to increase the messaging time, and we can increase messaging time for a particular user as well, right? Like for multiple devices. And for the servers, I can configure the static entry. Will not configure static entry for all general employee, just to keep the MAC address clean, right? But for the static devices like servers, we will configure the static entry, and static entry will be permanent in the MAC address table of switch. Now how to configure static entry? So guys, to configure static entry, simply you need MAC address, that's it. Now go to config t and say MAC address table, and then static. After that, whenever you don't know the command, you can put the question mark. Whenever you don't know the command, you can put the question mark. Now it is asking for what? 48 bits MAC address, right? So the MAC address of PC1 is this one. Let me copy it and let me paste here. Now it is asking for which VLAN you are going to add this MAC address, right? So for VLAN 1 by default, and then on which interface? So on interface E0/2. Done. Now so MAC address table. Now you see guys, for this MAC address type is static, and so MAC address table aging time. Is there any change? No. This MAC aging time is for dynamic entry only, not for the static entry. Now I want to find how this switch have how many static MAC address. So what I can say show MAC address table only static. It will show me the static entry only. I can say show MAC address table dynamic entry only. It will show me the dynamic entry only, right? If I want to check MAC address table for a particular VLAN, I can say show me the MAC address for VLAN 10 only, right? For VLAN 1 only. So I can open MAC address table with the help of MAC address. I can open MAC address table with the help of interface. I can open MAC address with the help of type like a static or dynamic. I can open MAC address table for VLAN. And even switch is not going to check every time their MAC address table like this to forward traffic, because guys, in real time there will be much informations, right? So if switch will check the entire table every time to forward one message, CPU utilization can reach to 100%, right? So if switch will receive traffic for a particular VLAN, let's say for VLAN 10, then it will check MAC address table for that VLAN only. It will not check the complete MAC address. Switch never check complete MAC table. And the MAC address table is also known as by CAM table. And where this switch is storing this information? In the running configuration. Running configuration means RAM, in the random access memory. So if power will goes down, then this information will erased. So to save this information, you have to copy RAM content into NVRAM. RAM is volatile memory, NVRAM is non-volatile memory. So I can say copy running configuration to startup configuration. Startup configuration, right? Like this, I can save the configuration. So forwarding is clear. Address learning is clear. First function. Yeah. Correct. Correct. No, so MAC aging time should be, see, we'll configure the MAC aging time according to our requirement. Like for the critical servers, we will configure the static MAC address. For the, like important departments, I can increase the MAC aging time. Or for rest general users, for general employees, I will configure the lower MAC aging time. Like I can configure the 100. Oh, see, let's suppose this is my network. I am network engineer of in this company, right? In this company have one server here. Fine. On this server, they are running one application. Like let's suppose this is HR portal. Fine. HR portal. Now, like this, I have multiple switches here, and then this switch is connected with one router. This router is connected with internet. Fine. And through internet, I have like this another branch as well, right? Here, these users in another branch office, like in data center, also there are multiple HR employees, HR people. They are accessing this server every day. Even user from here, from this branch offices as well are accessing this server. So I know this server is critical for me. Here I am running a critical application. So switch should have a static entry for this server. If I am the network engineer, that means I have information about the services, like which services are critical. Let's say if there are some finance people, and finance people are critical again, right? But not as server. So I can increase some MAC aging time for finance department. And let's say there are some general employees, right? There are some general employees, those are very general users. For them, what I can do, I can decrease the MAC aging time. Means I am telling to switch, bro, always keep information of server in your table, right? Keep information of finance people for long time, and keep information of these general employees for less time. Is it clear? And how to change the MAC aging time? So guys, to change the MAC aging time, simply, even you can find the command by yourself as well, but see, MAC address table and then aging time, whatever aging time you want to configure over here. If you will configure 0, what will happen? MAC aging will disabled, right? Means switch will not run any MAC aging time for any MAC address, right? So now let me configure MAC aging time, let's say 1000. Not for everyone. If I will hit enter over here like this, so MAC aging time is now 1000 for everyone. Now you can see the MAC aging time. MAC aging time is 1000 for everyone, right? But for a particular department, I want to change the MAC aging time. So I can say what? VLAN, let's say 10. And I will put all finance people in VLAN 10. Now do so MAC address aging time. Now you can see VLAN 10 exit interface is 0/3 switch port access VLAN 10, and so MAC address table aging time. Now you can see what happened here. MAC aging time 1000 MAC aging time. Oh, I have configured the same aging time. Let me do one thing here. Let me set, let's say 9999, right? And now so MAC address table aging time. Now you can see the global MAC aging time is 1000, but for the VLAN 10 MAC aging time is different. Like this, for multiple department, I will have different MAC aging time, right? Like let's say there is one VLAN 20 for different department for, let's say, the voice servers, and we have VLAN 30 for the, let's say, any other department, server department, right? So name server. So guys, according to our requirement, we are going to give priority to each department. And not only the MAC aging time, according to our requirement, we'll configure many more things. Like for the server, as the server is critical, we are going to configure more security, right? We'll configure more bandwidth between the switches. By default, you can see these switches are, means bandwidth is shared equally for all devices, but for the critical devices we will configure more bandwidth over here. So no one is going to tell you for which server you need to configure the bandwidth. You have to identify which one is the critical traffic, critical user, right? In a company, let's say we are configuring a SSID, a wireless network, for the guest, so that whenever guest will come in my company, they can access the internet. So we'll provide very less bandwidth, right, for the guest. More bandwidth should be available for the critical data, critical traffic. Sorry, your voice was breaking. Yeah, any other question? Only few people are asking question. Don't know why. What is happening in the group? Yes, Bezo. Sorry. Okay. Yeah, if you have not saved it in the running configuration, definitely it will erase, na. The running configuration, whatever configuration we are going to perform on the router or switch, it will store that in RAM. And RAM is volatile memory, means if power will goes down, then content will erase. But in real time, bro, you will have backup of configuration on servers. Even you will, take backup of your devices every day on a separate server, that is TFTP server or FTP servers. Every day you are going to check the health of your devices. And in the traditional network, this was very difficult. Just imagine the network of Google. Google have thousands of data center around the globe, right? And how difficult it is to manage, right, to check the health of their devices every day. So that's why we come up with what nowadays? SDN network, software defined networking. We are managing these devices through controller nowadays, right? Earlier we were checking the health of devices manually. We were accessing the devices. After that we were running the command so process to check the CPU utilization, right? In the traditional network, let's say I have 1,000 branches, right? And at each branches we have multiple networking devices. Let's suppose I want to modify the IP configuration, guys. How complicated it is, right? It's very difficult. It was very difficult. Earlier it was not much difficult because earlier network size was not complex, but nowadays network size is getting larger. Every day network size is increasing. Are you able to see the network on internet? Getting my point, guys? Yes, Behzad, is it clear? Jyoti, Santosh, Surya. Yeah, definitely I will tell you. Okay, so let's say this is my switch connected with PCs. Switch is connected with the router. And now tell me this user can access internet. Can this user access internet now? Where is the internet? Definitely no. So how this user can access internet? We need to connect up this network through uplink. ISP. ISP. Yes. Yes. Anything else? Any other question, guys? See, lots of people are there. Really, you guys don't have any question? But when I was learning CCNA, the trainer was like I was always asking questions. This is the reason why now I have a strong knowledge of CCNA because I had asked lots of questions to the trainer while learning. Questions should come in your mind, and if you are learning, then definitely question will come. If you are only watching, then there will be no question in your mind. If you will try to understand the things, definitely your question will come in your mind, like what will happen if I will do this, like that. No worry, I know later on you are going to ask all questions together. You guys are collecting, right? So guys, topic for tomorrow is VLAN. Topic for tomorrow is VLAN. So when I will ask you what is the topic for today, and before that, one more topic I want to discuss, that is SDM. Otherwise, you guys can also learn this topic by yourself. SDM, switch, database, memory. Or when we can discuss this topic while talking about the backup of configuration or restoring the configuration on TFTP or FTP. At that time also we can discuss. That is nothing but the you can say the technique which is used to manage memory on switch. Like guys, as I told you, MAC address table of switch can be get full. So actually you have option to allocate more memory to store MAC address, less memory to store VLAN information, or like layer 3 switch. Layer 3 switch can perform routing as well as switching. So we can manipulate the memory. The by default in the operating system is predefined, right? This size of memory is defined for switching, this amount of memory is defined for routing, right? But as a network engineer, we are allowed to manipulate that. We are allowed to change it. If we want to use a layer 3 switch only for switching, then we should allocate all the memory for the switching purpose, right? Not for the routing. We should configure zero memory for routing. Otherwise, you are not using the routing feature on layer 3 switch, but still your switch has reserved some memory there. That is SDM. After that, we'll discuss the VLAN, because there is nothing, I think, in Ethernet switch apart from SDM. Like, is my skin still visible? Now, so MAC address table and the count. See how many MAC address this switch can learn. This one, total MAC address space available. And out of this number, how many MAC addresses are there? One dynamic and one dynamic only. Zero static for VLAN 10. Okay, one over here, one over here. Means two MAC address. But if you want to increase more space, if you want to provide more space to store MAC address, you can. So SDM, I don't know, I can run this command on the simulations or not. Prefer no. So I have to access real switch. No worry. Tomorrow to discuss this topic SDM, I will access the real switch, and there I will show you how we can modify, we can manipulate the memory. If you guys don't have any question, you can leave the class. Meet tomorrow. Thanks for joining today. And now I am sending you